Before going for the long answers of chapter 13 thermodynamics, let us discuss the two SAQs, one work done in isothermal process, other work done in adiabatic process. So first, work done in isothermal process. So what is isothermal process? Iso means same. Here what is remaining same throughout the system? Temperature. If temperature remains same or constant, we call it as isothermal process. Same or constant throughout the system, we call it as isothermal process. Alright? Now let us go for the mathematical part. So consider an ideal gas of 1 gram mole or 1 gram mole ideal gas. Okay. P1 V1 be initial pressure and volume of gas. P2 V2 be final pressure and volume of ideal gas. Right? Now, work done. Okay, the work done in process, the formula is limits are V1 to V2 integral P dV. Now for isothermal process, PV is equal to RT. Right? From this ideal gas equation for isothermal process, PV equal to RT or P equal to RT by V. Now substitute this equation 2 in equation 1. Right? So now we will get work done integral V1 to V2. In place of P, we are substituting RT by V dV. RT constant I am writing out of integration symbol V1 V2 1 by V dV. What is the integration of integral 1 by x? Log x. So this is V is there, so log V. What are the limitations? V1 to V2. Okay, limitations are V1 to V2. Now substitute the limitations. First upper limit log E in place of V, V2. Keep minus. Now substitute lower limit V1 in place of V. Now you know that log A minus log B is equal to log A by B, right? Now following that RT, what we will write? Log E V2 by V1. This is work done. Now let us change this into base 10. For changing into base 10, multiply the equation with 2.303 RT log base 10 V2 by V1. So this is the work done in isothermal process. Alright. Now similarly, let us go for work done in adiabatic process. Work done in adiabatic process. So in our long answer, directly we will substitute the work done formulas. So you must be aware or known about how we got that particular expressions. Alright. Now work done in adiabatic process. So as usual, what is adiabatic process? the process in which no heat exchange takes place, no heat exchange takes place between system and surroundings, between system and surroundings. We call it as adiabatic process, the process in which there will be no heat exchange between system and surroundings, right? Okay, now let us go for the equation. As usual, consider 1 gram mole ideal gas, P1V1 initial pressure and volume, P2V2 final pressure and volume, right? Now work done in process, what we will write? W equal to integral V1 to V2 PdV. Now for adiabatic process, ideal gas relation or ideal gas equation is P V to the power of gamma is equal to K. From this P equal to K by V to the power of gamma, or we can write K V to the power of minus gamma. Alright. Now next, substitute here. W is equal to integral V1 to V2 K V to the power of minus gamma V. Here we substituted in place of P. Now K constant I am writing outside, V1 to V2 V to the power of minus gamma dV. What is the integration of V to the V to the power of minus gamma? How we will write? So x to the power of minus n x to the power of minus n plus 1 by minus n plus 1. This is the formula. Following that formula, V to the power of minus gamma plus 1 by minus gamma plus 1. V1 to V2. As usual, what we will do? First, we will substitute upper limit in place of V. So, V2 minus gamma plus 1. Now, I am writing this denominator outside. First, I am writing positive term 1, then negative term minus gamma. Now, next, here we will write minus sign, and next we will substitute lower limit. What is lower limit? V1 minus gamma plus 1. Now next, I will write this as, can I write this as V1 by V2 minus becomes plus, plus becomes minus, gamma minus 1 minus 1 by V1 gamma minus 1. You are simple mathematics. I am bringing into the denominator, minus becomes plus, plus becomes minus. Now next I am multiplying with K. K by V2 gamma minus 1 minus 1 by V1 gamma minus 1 K. Right? Now what is K? P V to the power of gamma equal to K. So here 2 is there. So just write down P2 V2 to the power of gamma in place of K by V2 gamma minus 1. Here 1 is there. P1 V1 to the power of gamma in place of K by V1 gamma minus 1. Alright. Now just I'm writing this as P2 V2 to the power of gamma, by I'm separating this. How can I separate V to the power of gamma into V to the power of minus 1? Here V2. P1 V1 to the power of gamma by V1 to the power of gamma into V to the power of minus 1. Can I write this in such a way? Yes, I can write. So now strike off the same terms. Now what is remained? P2 by V2 minus 1 minus P1 by V2 minus V1 to the power of minus 1. Now 1 by 1 minus gamma, P2 by How can I write this? 1 by V2 I can write. P1. How can I write this? 1 by V1. Now what happens? V2 goes into the numerator. P2 V2 minus P1 V1. V1 also goes into the numerator. Now next, we know that P2 V2 PV equal to RT, no? RT2. Same, I am following that equation only. P1 V1 equal to RT1. Here there is no heat exchange, but temperature in that particular system changes. So initial temperature be T1 and final temperature be T2. But heat never exchanges between system and surroundings, but in the system itself temperature compulsory changes from T1 to T2. Now substitute these values. 1 by 1 minus gamma R T2 minus RT1. Take R as common. 1 by R by 1 minus gamma T2 minus T1. This is the equation. Or you can also write it as W is equal to R, taking minus as common, gamma minus 1 T1 minus T2. So this is all about work done in adiabatic process and work done in isothermal process. Thank you.